I'm going to just talk briefly about the core Hypervisor project and exactly where we are at the moment in terms of releases and what our plans are kind of in the near and mid-future as we now carry on working towards a future 4.1 release. So, wait a minute. Slideshow, like that, from beginning. Brilliant. Right, yeah, so where we are at the moment is we have this kind of ongoing strategy that we try and keep, as far as possible, two stable branches kind of going in tandem at any point in time. So as Ian mentioned, we made the brand new 4.0.0 release just a couple of weeks ago. And obviously we want to be moving people over to that. But in parallel, we realized that, as you might expect, a new .0.0 release may not be stable enough for everybody's uses. And there are a number of people, including ourselves, who have a great deal of investment in the 3.4 branch. So we are continuing to maintain that. The last release out of that was actually a while ago, back before Christmas. So the current release there is 3.4.2. However, 3.4.3 is imminent. I plan to be doing a final release candidate for that in the next few days with a view to getting that out the door probably next week or soon after. And then ongoing, we probably will be doing, for example, a 4.0.1 release in the next month or two, and then a 3.4.4 and a 4.0.2 and so on, going on from there. And then the 4.1 release, well, we found that a good balance there between not overwhelming users with new major releases all the time versus developers getting there and companies getting their features out into a stable branch within a reasonable time frame indicates that kind of 6 to 9 months between major new stable branches is about right, which probably means that we're looking at 4.1 around kind of the tail end of this year. And so actually what I'm going to talk about for the rest of my time is some of the features that you can expect to see in that 4.1 release. So indeed, the kind of way I came up with this list almost was, as you might expect, the 4.0.0 release process has been kind of protracted. So we actually froze development for the release before Christmas, so back in December, and we didn't actually get the release out. We kind of managed to boot it out the door finally just a couple of weeks ago. You find there's this kind of built up kind of big set of patches which all the developers are just waiting to dump on me basically as soon as development reopens. So I had I guess I got a list here of the features which were kind of foremost in my mind, because I know that I've got patches that I've just checked in or are sitting in my inbox waiting for my careful review. So one of the first of these is the kind of the new scheduler that we're going to be having in 4.1. And this is mainly the work of George Dunlap, who actually is going to be talking in more detail about this tomorrow. And it's basically driven kind of in two ways. So primarily it's about measurement of the scheduler, the Credit One scheduler we already have, to see how that is working with the kind of workloads that we care about, and then coming up with a new scheduler to address its weaknesses. So in that respect, Credit 2 Scheduler is as much or more about being kind of a pragmatic, workload and empirical results-driven kind of solution as it is about some kind of new architectural grand design. So, well, maybe I'll talk briefly about the kind of the history we've had. We've kind of got this pluggable scheduler framework in the Hypervisor, and that's been quite good because we've had a bit of to some extent, a revolving door of schedulers over the years. So we started off with what we call a deadline-driven kind of model of scheduling, where you'd be able to say, I want a domain or a virtual CPU to have this amount of CPU time, this frequently, and you'd work out when your scheduling deadlines are and make sure that your domain got to run pretty regularly. The aim for that was kind of, in particular, to deal with kind of real-time applications, kind of multimedia apps, that kind of thing. We moved away from that and we moved to a simpler model of weighted fair share scheduling with the credit scheduler, the reasons being that although we had extra twiddly knobs on the earlier scheduler, the problem is that most people don't really know what you should set them to, and they just want a niceness or amount of CPU kind of knob to adjust. Also, it dealt with other issues with the earlier scheduler, such as actually doing load balancing automatically across multiple physical CPUs, so that you actually get automatic balancing across larger multi-core, multi-processor systems. Some of the problems we found then is with George's measurements are that by moving totally away from that deadline-driven scheduling, there are actually applications we found, particularly with our looking towards kind of client virtualization now. It would be nice to have slightly stronger guarantees about how frequently virtual CPUs run. So, for example, if you're running a guest domain which is running, Real Player or something like that, you actually want to get video and audio working smoothly and nicely, you actually need to be giving some stronger guarantees about when that virtual CPU is going to run in order to not have audio drop out and the video be choppy. We also found that although the credit scheduler has this greedy scheduling algorithm and a work stealing strategy for moving work between non-idle and idle physical CPUs, it's actually surprisingly aggressive about doing that and probably is a bit more keen to redistribute work than it ought to be. And there are optimizations which can be done there. Okay, so I'll move on from this point. Only point out that the Credit 2 scheduler has now been checked into the development tree as of about a week or two ago. And it's not the default scheduler as yet. George doesn't quite have as much confidence in it as we need for that at this moment. But he's actively working on that. And we'll be switching that to be the default scheduler in our development tree in the near future. While I'm talking about scheduling, another feature which got checked in just recently is a feature from Fujitsu called CPU pools. I guess this is kind of, the target for this is kind of the kind of big iron systems which a company like Fujitsu is well known for producing. The idea being that you've got a large machine, a big iron system, and you want to be able to partition its physical resources. And we kind of have support for that, had support for that already in terms of CPU resource, because you could specify a CPU affinity for any given domain or group of vCPUs to constrain the number of physical CPUs across which they can run. The aim here is basically to give a nicer kind of administrator kind of tool set for configuring this thing. So you can define a number of CPU pools, physical CPUs, each physical CPU maps to a particular pool, each domain could be mapped to a particular pool, and then all the affinity, mask setting, and things like that are automatically dealt for you under the hood. Also, by implementing this down into the hypervisor itself, there's scope for doing funky things like running different schedulers or schedulers with different global parameter settings in those different partitions so that you could run your soft real-time scheduler for your multimedia workloads in one, and you run a different type of scheduler in another. That's something that could be looked at down the road. Kind of on that topic of big iron, one of the big things which we're looking at getting sorted out in the near future is better and easier to use NUMA support. There's been work on this and patch sets mooted from Dalur at Georgia Tech and from Intel and from AMD, kind of all looking at how to efficiently execute and manage guests on bigger systems which have NUMA characteristics. And the strategy which seems to be generally agreed upon going forward is to provide a small set of of possible strategies to the user, and they can decide, for example, whether they want to configure a guest to be confined to exactly no more than one NUMA node. So you define its affinity mask and so on to run within that NUMA node. All of its memory should preferably be allocated from within that single node. And then the guest itself doesn't need to know that the underlying physical system is NUMA because it's completely confined to one node of that system, and so from its point of view, its memory accesses have uniform characteristics. Or another model would be, maybe you've got a guest which itself doesn't have NUMA awareness, but is too big to fit inside a single NUMA node. Well, another strategy then would be to stripe it and to say, well, if I can't completely confine it within a single node, I'll at least stripe it across multiple nodes, kind of evenly spread out, so that on average its performance is not ever unexpectedly poor or unexpectedly poor. It gets kind of an average performance. And a split strategy, which would be for, again, running on multiple nodes, but in this case, the more interesting case, you'll have a NUMA-aware VM, whether it's a fully virtualized HVM guest or a PV guest, and we will allocate its memory and its physical CPUs across the NUMA system, and we'll somehow cook down that topology information and get it pushed into the guest so that the guest itself can make scheduling and memory allocation decisions based on the memory characteristics. So there's actually a talk in more detail on that from Dalur and Jean, I think tomorrow. So you can ask more questions of them about that. Another feature which I've received 2 very large patch sets for in the recent days is nested virtualization. So the story here is basically that this is for HVM guests, so fully virtualized guests, the aim of which is usually to provide transparent, seamless virtualization of all the features of the underlying processor. Well, as you probably know, Intel and AMD processors both have their own sets of virtualization extensions which make it possible to do that efficiently these days. But of course, since Zen itself makes use of those features, we actually end up providing a virtualized experience where within the guest itself, you can't make use of those features because we're already sitting on them and using them. So the story here is to provide sufficient virtualization/emulation of these virtualization extensions so that the guest can still make use of, say, VMX when running inside HVM on an Intel CPU, or similarly make use of the SVM extensions when running on an AMD CPU. Now, this is one of the kind of features which we've had developer interest in for quite a while, and the patches have kind of been on the boil. And there are some uses for this. I have to say that it's a feature where developers think it's cool, and thinking of the real end user possibilities for it is a little bit trickier. One of the things, so again, talking about the kind of client virtualization experience, one of the models there is you're providing a user with a desktop or a laptop where the hypervisor is in some way kind of embedded kind of in the system software at the lowest levels of that platform. And if you're trying to migrate users over to that, well, they might have their own kind of, I might call, legacy virtualization platforms which they're already used to using. And it would be nice if, when they move on to this new virtualized up laptop, that they don't have to immediately throw away their existing whatever virtualization product they're using. Another usage case for it is of course, hypervisor testing, which is one reason why developers like it so much. You can run a stable version of Zen, and then you can do your testing of your new bleeding edge version of Zen on top of it, and it's more manageable and more easily rebootable and so on. The story for this, as I said, is we've got patch sets for both the VMX on VMX case and the SVM on SVM case, and there's just some thrashing out to be done of how much kind of architecturally at the HVM kind of common code level, how much of the implementation should be shared versus how much of it should be specific to the to the particular VMX versus SVM specifics. But that should still be in the tree probably again quite shortly in the next few weeks most likely. Finally, briefly, I'll touch on the tool stack. So, as Ian's already kind of discussed, libzenlite is one of the big changes that's coming down the pipe for tool stack in the Hypervisor project. Again, the aim being that we actually have a whole host of different tool stacks now for the client project, for Zen Cloud Platform, and kind of ZenD, the old ZenD tool stack in Zen in the kind of core Hypervisor project. And I guess certainly they all have kind of slightly different models of how they drive the system and the kind of management model they expose. But equally, it kind of leads to fragmentation of development effort, and there's a whole bunch of low-level kind of aspects of how these tool stacks inevitably work, which ought to be shared rather than having redundant, duplicate versions of the same code. So the story here is that, well, the project was started before 4.0 was released. Actually, the code went into the tree back in, I think, last October. But since 4.0 has been released, still with ZenD as the primary supported tool stack, we're now looking forward to 4.1. We're looking at really de-emphasizing the ZenD development and trying to get libzenlite and its XL tool, kind of the equivalent of ZenD's XM, up to feature parity with ZenD so that we can switch users over to the new tool stack by default. Now this, I think, is actually helped by the fact that when developers find out that they don't necessarily have to actually wade into ZenD and implement their new hypervisor features through the twisted Python mess of ZenD, they can instead do it in the nice, relatively lighter weight libzenlite and XL tool. They're usually quite happy to hear that. So there's actually been quite enthusiastic, I would say, developer participation in filling in the gaps in libzenlite's feature list. Again, Stefano will be talking about that at the end of the last session tomorrow. Another tool stack related thing that's cropped up is looking at replacing some of the lower level daemons such as ZenStored with versions which we've been using ourselves are written in the language OCaml instead. The proposal at the moment is that we will put these into the tree and build them and make them available as alternatives to use in parallel with the existing C versions, and we'll kind of take a suck it and see kind of approach to see how people get on with those. We kind of recognize the fact that at least with a C daemon, if you have problems with it, developers are able to kind of usually wade into C code and work out what's going on and fix it for themselves. There's not always that existing base of expertise when it comes to a language like OCaml. Of course, we hope that the OCaml doesn't have bugs in it, but we will see how that goes. In the particular case of the OCaml ZenStored daemon, it does have it's undoubtedly a lot smaller than the C version. Also, it has a more efficient model for storing the ZenStore database data in memory rather than in a file on disk. So it has better performance characteristics, and it's a smaller code base to maintain. So we're kind of dipping our maybe just 1 foot in the water on this one for now to see how people like that. So just to close up, my usual kind of informational message on how you go about contributing your patches and how the kind of development process works. So the number one thing is if you've got patches you've got ready and waiting to get checked in, or you're thinking about starting work on a new feature, or you want requests for comments on a feature you're thinking about, or any of the above, then get in touch with the developers on the primarily on the ZenDevel mailing list. The earlier that you get in touch and talk about the feature, the more help you can be given on kind of synchronizing with other developers who might be working in related or identical areas and get ongoing review and guidance. There are also separate lists which for the Zen client initiative project and also for Zen Cloud and the Zappy tool stack. So you can also find developers registered on those lists as well. And there's also the wiki, which has been actually to a large extent kept up to date by Pazzi. And one of the pages on that is the Zen roadmap, which we've been updating since 4.0 has gone out the door with feature requests and development proposals for Zen 4.1. Okay. That's all I have to say. Thank you.